operations with radical functions with a focus on the composite function. The composite function means that we are taking one function and putting it inside of another function. You'll see on this slide that there's two different notations and they both mean the same thing. So we can have f with kind of an open circle and then a g, and that means that the g function is on the inside of the f function. Or you can actually write the g function inside of the f in the parentheses. They mean the same thing. When the two functions are put together, that is called the composite function. We talked in the last video about domain, and when we find the domain for a composite function, we have to consider the domain of the inside function. So if the domain of the inside function is anything but all real numbers, then it will have an impact on the overall domain. We're looking at the intersection between the domain of the inside, so in this case it's g, as well as the solution. We do not need to look at the domain of the outside function. So here is an example. We have a square root function, so a radical function, and a regular function. Before we actually find the composite function, let's identify what the domain is. So the g function, which is our inside, this is a line because it's in the form mx plus b, and the domain of a line is always all real numbers. So we don't actually have any restrictions for that inside function. We're going to put the g function inside of the f function. So the individual domain for f, we don't need to find. So I'm going to rewrite this, and instead I'm going to rewrite this g of f of x. Now I'm going to replace g of x with the expression 2x minus 5. And then I'm actually going to input the expression 2x minus 5 into the x values for f. So we have the radical, and then plus 7. So notice that in our f function, this x has been replaced with g, and g is 2x minus 5. And then I'm going to simplify. So we get 2x plus 2. To find the domain, there are a number of different ways you can actually identify the domain. One is by taking the expression underneath the radical and setting it greater than or equal to 0. So we're going to take 2x plus 2 and set it greater than or equal to 0. So what we're saying is that that expression has to be 0 or a positive number, because you can't have a negative number underneath the radical. So the final solution is f of g of x is equal to the square root of 2x plus 2, and the domain is that x values have to be greater than or equal to 1. Example 5. What is the rule for the composition of f of g of x? So we are putting g inside of f. Before we do that, let's look at the domains. The domain of this linear is all real numbers, and the domain of the quadratic is also all real numbers, but we only really need to focus on that inside domain. So I'm going to replace g of x with 4 minus x. Then I'm going to replace the x values in f of x with our new expression 4 minus x. So we get 4 minus x squared plus 4 minus x plus 2. we're going to simplify. 4 minus x squared, we will have to FOIL. So we get 16 minus 8x plus x squared. And we can collect like terms. So our composite function is x squared minus 9x plus 22. And the domain for this quadratic is all real numbers. So that means that the domain of the inside is all real numbers, and the domain of the composite function is all real numbers. So therefore, the final solution has that exact same domain.